Hi everyone, it's Crystal, and I'm sorry I couldn't be there with you today and tomorrow for the meeting, but I wanted to give you a quick update on the watershed work. And first, I want to point out sort of the extent of the Landsat scene I've been working with. This is a false color image from that Landsat scene from 2008, so you can easily see where Monterey is and the 2008 fires that hit a fairly large portion of Big Sur and the Ventana wilderness that year. So first I want to talk about the low resolution inputs, and the low resolution data are the MODIS data. So the three MODIS products that I'm using are the leaf area index, which is an 8-day composite. It's available from 2000 to 2010, but they didn't collect data for the first part of 2000. So realistically, this is a 10-year coverage from 2001 to 2010, and LAI is in 1 kilometer pixels. The snow cover is also an 8-day composite, again from 2001 to 2010, because 2000 is incomplete, and it's at 500 meter pixels. And then the land cover is an annual product. It's actually not produced by NASA, but instead by Boston College, and they have not updated the last 2 years, so we have 2001 to 2008 for land cover, and it's a 500 meter data set. So for these three data types, land cover, I was primarily looking just to change mapping, but there's other types of variables that can be produced, such as percent change, persistence over the period of time. But with the temporal information, the leaf area index and the snow data, what I wanted to do first was look at some time series to understand sort of the peaks and the cycles within an area of interest, or AOI. And I also wanted to talk very briefly about the idea of trend versus variability, which will become obvious here in a minute. So first, just an example of the annual land cover product. I apologize for the really funky color scheme on this, but a couple things to point out that are fairly obvious. One is this class 1, this sort of dark pinkish rose color. This is a evergreen needle leaf forest. So there's been a reduction according to this classification of the evergreen needleleaf forest, the pine forest in the high elevations, and then the redwoods in the low elevations along the Ventana coastline, or Ventana wilderness area there. The second area that's sort of interesting is sort of this dark purple class 7. That is an open shrubland, and it's set against class 10, this sort of greenish color, which is grassland. So this change from 2001 to 2008, according to this classification, is a regeneration of shrubs into this grassland. If this classification is correct, that's sort of the ecological translation. When we just simply look at a change matrix between these two for the 16 classes that are produced in MODIS, you can see there's quite a bit of change all over the place, and this is a percentage of all the pixels for each one of these boxes. So for example, class 8 is a woody savanna class. So in the change from a woody savanna to a closed shrub occurred across 1.2% of the pixels between 2001 and 2008. That's how I'd frame each one of these numbers. So looking at sort of the temporal trends, when we're talking about leaf area index and how it's potentially meaningful for the questions that we're asking in this project, I was trying to come up with some ways of assessing that and producing some variables. So one of the ways to do that is through a program I have called the Earth Trends Modeler. It's with the Adresi Clark Labs software evaluation product. And this temporal trend in the graphic here is showing the seasonal cycle of greenness, such that each year greenness occurs around end of February into March, and then for the rest of the year the vegetation is senescing. to the point where the low greenness occurs in late October and into November across the area of interest, which in this case is simply a circle I drew that covers the northern part of the Salinas River Valley and much of the Big Sur region and the Ventana wilderness area. And so this is this line is the trend for the median leaf area index within that circle value. Realistically, we can draw any kind of polygon we want, including watersheds, and come up with this line so that you have a linear data set by either month or by moving average or by individual date across this period for this spatial extent. That's a potential variable. Snow cover is something that we've talked about quite a bit. For California, the MODIS snow cover product has really poor accuracy. When I started looking at these data, I realized that there were quite a few dates when it looked like the entire Sacramento Valley was covered in snow. And I realized that it's mistaking tule fog, that thick, dense valley fog, for snow. The algorithm isn't fine enough to sort the difference between those two. It also appears to make some mistakes in barren areas, including recently burned areas, where it thinks that the high reflection is actually snow. And there are dates when there actually is snow that the product is not picking that up because coastal snow is sort of a dusting in this region, not a big thick coat, so it's difficult to pick it up. So the snow cover product, I think, has poor accuracy, poor reliability in California, and is probably not a good variable for this region. For these leaf area index and snow variables, one of the things that I sort of need some input on from all of you is, what is really needed? There are so many different variables that could be produced from this. So some of the things that could be produced are things like, what is the total cover of snow or leaf area over some time period of interest? For a given polygon or a watershed for the entire 10-year period, there's a percent coverage for that watershed or polygon. There can be an annual departure from the 10-year mean, and that could be relevant for the sampling year or the year before the sampling year. It's really easy to make up hundreds of variables with this type of data set, but what's particularly relevant? And I'm afraid I don't know enough about how you do wildlife studies to really be a great expert on that. I want to also point out that we've talked a couple times about trends, but trends over 10 years are not significant. So what might be better is to look at some of the departure from the 10-year average during the sampling period or during the year prior to the sampling period if you're interested in sort of the reproductive rates or something along those lines. And potentially associate those departures with climatology.